Hello guys, welcome to yet another video, and let us look at this question 5. It was quite interesting actually towards the end, and it's some of the things I've been backing all year through as to what techniques must you learn so that you can solve certain problems, because you never know how they are going to dictate how those questions should be solved. So let's look at this question 5 and see what is going on. We are given here f of x is equal to minus a half into x minus 1 all squared plus 8. So we can see that this is a parabola in turning point form. So obviously this is our a value, and our a value is less than 0. So this means our graph is a grumpy face parabola. And do we see something like that? Definitely we see something like that. Okay. Okay, that's the first thing. And then from this, we know that the turning point is going to have the opposite sign of what is inside the square. It's 1 and that constant, so that's 8. Okay, great. So these are the things we can gather from this function, and we can see that. So let's read on. We are also given g of x is equal to d over x. So this is the standard hyperbolic function. Can you see? It's not shifted about at all. And as we look on the graph, we can see the graph is in the first quadrant and third quadrant. This is suggesting that our d value, that d here, is a value greater than 0. Okay? Because when d is greater than 0, we know that our function is in this format. Okay? That being the axis and the origin. Okay. So this is just a quick analysis you can do to move on. So let's read. Now we know that these two graphs are drawn below. Okay, a point of intersection of f and g is b. Okay, so we know that this is the point of intersection for the two graphs, and obviously we know that we're told b the turning point of f. So now if this is b the turning point, so this is at 1 and 8. Okay, right. The graph of f has an x, okay, has x-intercepts minus 3. Okay, there it is, we can see that, and 5. Okay, we can see that. No problem. And then we are told here, and a y-intercept at c. So now the point c here is going to be such that we've got some 0 into some particular y value, which we will need to determine. At this point, this format doesn't tell us the y-intercept. We will have to work it out. Okay, all right, no problem. So just a quick analysis to understand your graphs is important. And let's move and start answering the questions. So 5.1. We are told here, write down the coordinates of the turning point of f. So we know that b is the turning point. So b is going to be 1:8. Easy stuff. So you get 2 marks for those coordinates. 5.2. 5.2 says calculate the coordinates of c. Can you see? Now we're looking for the y-intercept. And easily, y-intercept, so we know that c is the y-intercept of f. Okay, such that now you know where you see f, this is now going to be f of 0 is equal to minus a half. Where you see x, you put a 0, minus 1 squared plus 8. You just plug that into your calculator. Makes life easy here. So minus 0,5 into minus 1 squared plus 8. So we're getting a 15 over 2. So 15 over 2 is 7,5. So you can either write it as 7,5. It's still okay. So now what did we say? Coordinates of C. So therefore C is going to be this point 0 and 7,5, or we can just write 15 over 2. That's our answer. Okay, great. So here the 2 marks is scored from substituting 0 where x is and writing our coordinate. Or you can easily say the answer here, because this is just, a continuation of what we already did. All right, so 5.3. So you guys, we need to cry nice, like easy questions. Calculate the value of d. Can you see? Now we know that d is on g of x, which is equal to d over x. But now we know that through point B, because B is a point of intersection of the two graphs, now we know the coordinates of B are essentially 1 and 8. It is such that 8 is going to be d over 1. You can say therefore d is equal to 8. So do you see, we expected a positive value and we are getting 1. So here the answer is that which gets the mark. Okay, moving on. We are told now write down the range of g. So 5.4. We want the range of g. Now g is the hyperbolic function. As you can see, this hyperbolic function will go to infinity, negative infinity on the y-axis. And it will go to positive infinity also on the y-axis. But we don't see this graph intersecting the line y is equal to 0. So meaning the asymptote is on the x-axis, or the line y is equal to 0. So all we're going to write here, we're going to say the range of g is equal to a set of y values such that y is an element of real numbers, but y is not equal to 0. Okay, so I'm just writing it in a silly way. So you can just write y is an element of real numbers and y must not be equal to 0. So that is how this is done. So you get your mark and you smile on. I'm gonna cry nice, guys. You are overly prepared for these questions, I'm sure. So let's do 5.5. So 5.5 says, for which values of x will the y values of g of f, can you see this is the y values of f multiplied by the y values of g, be less than or equal to 0? Okay, so we only get that when either one is less than or equal to 0. So let's see, but this must be happening at the same time. So now at the points of intersections, maybe let's use another color. At the points of intersections, these graphs, the y values are the same. Can you see there's 3 points of intersections here? So we know that at that point, we essentially are going to have a scenario where these are going to give us 0. Okay, so we got zeros there. So when we multiply those two, no, we don't get 0. What am I saying? I'm lying. When we multiply these two here, can you see this is minus something? So this is a negative y value right there. So it's some minus y value. Okay, so this means if we multiply a negative y value by a negative y value, what do we get? A positive y value. So that means this portion of the graph is not accepted. So we cannot take that. Okay, all right. But now what do we see? We still see this all the way until that x-intercept. Can you see? Until that x-intercept, because now both of them are negative. So a negative times negative gives us a positive value. So this means this whole interval going to infinity to that is not allowed. Okay, So we go on and say, fine, we understand that. Now from this 3, we can see this one is at 0, right? And this one is at some y value. So 0 multiplied by any value is going to give us 0, and 0 is included. So that situation right here is good. Okay, maybe let's choose another color. So we know that, okay, this portion here is included. All right, great. Now, as we move along to the right, we will see that this one is positive, this one is negative. So that product is going to be less than 0. So this means this interval is included. Okay, we go on. But now, when we reach 0, we want to stop, because if we go beyond that, we can see that this one is positive, that one is positive. The product is going to be essentially this interval, basically, from here to there. This interval is suggesting that no, man, we have a problem, because here we've got a positive multiplied by a positive up until this one is 0. So this interval is not accepted. But from this value, because this is at 0, 0 multiplied by any value will give us a 0. But going further into this direction, we can see that this is positive, this is negative. So this means that product will be less than 0. So this means this interval is correct. Okay, so how many intervals do we need here? It's these 2. Okay, great. Now let's answer the question. So here we're using the graph basically. So we are going to say x must be less than, can you see? It must be less than 0, but greater than -3. But is -3 included? The answer is yes. -3 is included. But 0 cannot be included. Why? Because the hyperbola on that line x is equal to 0 is undefined. It's an asymptote. Okay, so comma the next interval that is acceptable, we know that x must be greater than or equal to 5, because 5 was included going to positive infinity. So essentially that's how those marks are scored. So this format, you get 2 marks and then 1 extra mark for that one. Nice and easy. Le nto ibizwa ngama-cry nice ke bafowethu, ngama-cry nice la. 5.6. Now 5.6 says calculate the value of, it says calculate the values, can you see, values of k so that h of x is equal to, can you see, the function of h is equal to -2x plus k. Obviously k is a constant here. Okay, will not intersect the graph of g. So if we're saying will not intersect the graph of g, this means non-real roots. Can you see? This is a question on the nature of the roots, which you guys know so well. Now, this is where those techniques I taught you of using everything, be it the graphical method, being the algebraic method, using the table or whatever. This is that question right now, because you can see it says calculate. So this means you're not going to use this graph and just look at it by inspection and determine the answer. The question didn't say determine. So you can't just inspect here. And at the same time, we know that, look, the gradient -2 here doesn't make any sense, because the axis of symmetry for this graph is the line y is equal to x and the line is equal to -x. So the gradient is 1 and -1 of the axis of symmetry. So we can't even use those axes of symmetry to say maybe this is related to the axis of symmetry with the negative gradient and then some y value that we can think and figure out. Okay, but now this is a totally different function that has nothing to do with this. But then we are saying, when will this particular function, as unrelated to this as it may be, when will it not intersect this graph? Because it is any graph for that matter, and it could easily intersect the graph of G. So when will it not touch the graph of G? So we're saying for non-real roots. So the first step here is to just say, first of all, G of x is equal to this h of x has non-real roots. Or we can say, maybe let's start it by saying it properly. We can say for h of x equals 2 minus 2x plus k to not intersect g of x, it is such that we can simply say h of x equals g of x has non-real roots. Trust me, this thing, guys, or maybe let's say it's not even to say that, we can say it implies that, right? That's what it implies. Okay, this is just to say, okay, you're giving us this statement. How do we interpret this statement? This statement essentially means h of x equals g of x must have non-real roots for them not to intersect. So non-real roots, what do you know about non-real roots? It means the discriminant must be less than 0. So can you see, these are the things you need to think about. Sometimes these questions are not that difficult. It's just a matter of understanding what is the cause of action you should take. So let's proceed. Okay, we can say this implies h of x is minus 2x plus k equals g of x. We found out that d is 8, and then the denominator is x. And then, of course, this is all over 1. So we do our famous gymnastic of cross multiplication. And then what do we have? We get x into minus 2x plus k is equal to 8. So this dictated you solve algebraically, because there's no knowing this. Okay, unless you can have a graph that is drawn to scale, you draw one, but again you'd be confused. There will be a lot of problems. So we foil this, is going to be minus 2x squared plus xk, or let's just write it properly and say kx, because k is a constant. Kx, then we transpose the 8, minus 8 is equal to 0, because for us to solve any quadratic, be it nature of the roots type of questions or whatever, we need to put it in standard format at least. Now we can see here that, oh, okay, we've got minus 2, which would be a, and we've got here k, or plus k. We've got plus k. That gives us our b value, and we've got minus 8 as our constant. So this is our c. So we know that essentially for non-real roots, it is such that delta must be less than 0. We know that when the delta is less than 0, if you say square root of a negative number, your calculator says a math error. B squared minus 4ac must be less than 0. Great. So this question was a nice question. And this implies that now b is k squared minus 4. This is minus 2 into minus 8 less than 0. Okay. This is k squared minus 64 less than 0. Okay. Because this is going to be plus 8 times minus 8 is going to be minus 64. So again, don't solve quadratic inequalities by transposing that to that side and solving. You're going to run into problems. This is basically a difference of two squares. Factorize. That's why you need to learn factorizations and master them. Now this is going to be k plus 8, k minus 8. Again, guys, you look at our problem and you'll be like, okay, now we're basing the solutions here. We're basing these solutions on this quadratic inequality, okay? just be mindful that that is our quadratic inequality of interest. So now you've got all the techniques. You can see that the coefficient of k is positive. So this means you can use your graphical method here to solve this thing. Obviously, this is a parabola with a constant, so the axis of symmetry is essentially the y-axis. So this means our parabola is going to look something like that. Okay, so this one tends at this point right here, and that of course is going to be minus 64. And then this is going to be minus 8, this is 8. Okay, great. So when is this less than 0? It's less than 0 in this region. Okay, so how do we then conclude? We can say therefore k must be less than 8 but greater than minus 8. And that is the values of k for which our essentially composite function would not have real roots, which is what this means. You can even check this. A value less than 8 greater than minus 8, it can be 0. Take 0 for convenience. If you place 0 for k there, what do we get in this expression? So you're taking it from here now. We're saying k is going to be 0 because we're taking any value between 8 and minus 8. This means we just want to check if we're going to get non-real roots. So let's see, we're going to have here minus 2x squared. This one falls away, minus 8 is equal to 0. And how will we know if we have non-real roots? Well, we try and solve this by using the discriminant, is it not? Let's use the discriminant and see. So we have here b squared is going to be 0 squared because there's no b value, minus 4 into 8 minus 2, c is minus 8. Okay, this is basically going to be 8 times minus 8. It gives us minus 64. Can you see this is what would be under the square root when we solve? So we can't have a square root of a negative. So it definitely says there will be non-real roots if k takes any value less than 8 greater than minus 8. So there are ways, guys, to try and brainstorm certain things, and you know that whatever you calculate, you should not be surprised by a wrong answer when you see the memo. You can check it. So whenever you've got equations, you can check your answers and be convinced on the go that you've got it right. Okay, so that was the tool. You could use my algebraic table. Maybe you want to practice it, do you? Yeah, doch. Let's leave it for now. We don't want to confuse people anymore. It's already injury time. So let's do 5.7, the last question. So now it says if h is a tangent to g, can you see this very h we're talking about? Because there's no other h we spoke about. So if h is a tangent to g, now for h to be a tangent to g at point r, it means the gradient of g at r is equal to minus 2, because that is the only thing we can learn from that expression. It is that gradient of minus 2. Ne? That is what we can learn. Okay, so that was meant to be r is minus 2. Now it says a point in the first quadrant. So meaning this point r is any point in the first quadrant. So let's assume this is this point r here. We don't care where it is, but we're going to say that is our point r. And obviously our point r is going to have some x value and some y value that we may need to find out. So this is our special guy. Now we are told also, calculate t such that y equals f of x plus t intersects g at r, meaning they have equal roots there. So can you see they're giving you a combination that has nothing to do with the other one, but the other one has something to do with the link, okay? It's like a love triangle, which is dangerous. Don't do love triangles. In fact, you guys stay away from just anything that has to do with the so-called relationships. But love triangles are dangerous. So don't do it. So this is a love triangle actually. So this one is pulling this one is pulling that one because there's a common link. Okay. However annoying that may be. So now we have to calculate. Again, can you see calculate? This means we're going to have to deal with this algebraically. It has nothing to do with this graph per se. You won't look in this graph and find these solutions. Now we have to do an algebraic determination before we can put it on the graph. But this information that this thing must be in the first quadrant is already indicating that should we find the coordinates of R to be any other point than one in the first quadrant, then we are wrong. So this is trying to give us a direction that whatever point R is, we need to find it to have a positive X coordinate and a positive Y coordinate. And if that is not the case, then it means we are wrong with our calculation. So can you see, it's a tough question, but you can essentially tell when you are wrong or right. Okay, let's go guys. Very easy stuff after all. So first of all, what do we know? If this graph here, if this graph intersects G at this point R, it means the gradient of this graph is also going to be equal to 2 at that point. Can you see that? So it means the gradient of this function as well will be minus 2. So that means we're going to apply calculus. So this is essentially a grade 12 question here. Grade 11s are falling away from this one. The rest of the other questions were all grade 11, but this one is purely grade 12. Okay. So let's sort it out quickly, guys, before 30 minutes are done. I have a lesson with my guys to go to. All right, I'll do the others later. Okay, all right. So our plan of attack is to write this one. Y equals f of x plus t. Okay. Now let's sort this one out. F of x is what? F of x is minus a half of x minus 1 all squared plus 8 plus t. So now this is the t. So when we FOIL this thing out, we're going to have a minus half x squared. Can you see that? Then here we're going to have minus x is going to be minus 2x. Minus 2x times minus half is going to be plus x. Okay. Then this one times plus 1 is going to be minus a half again. Okay. Then we have plus 8 plus t. Whoa. Now that is quite interesting, is it not? This implies when co-implies yandola. Sumqhele. Waniphaphela. Lahlisa umlilo. Okay, we've got minus half of x squared plus x. Now let's sort this out. This is going to be 2 times 8 is 16. 16 minus 1 is 15. So this becomes plus 15 over 2 plus t. Okay. So we are good. So now we've got this one. But now we are told that the gradient of this function, since this function is equal to, essentially, if this function is equal to, wait a minute. If these two graphs are equal, at this point, ingathi khona inkinga nyana esizawuhlangabezana nayo ngoku as I'm looking at this. Because how do we work this thing out? Well. But the suggestion was, if this is a tangent to G, and then we are shifting also this graph, it means this should be a common tangent. I would suppose this is a common tangent basically. because basically, let's say this is r. That means we're shifting this graph vertically because we added t. If we're shifting this graph vertically, for them to be here, it probably would be something like this. Okay? So this tangent here becomes a common tangent to both. Can you see? So yes, basically, it means the gradient is going to be -2 as well for this function. So let's just go that route. Wrong or right, we just have to go now. But now we know that essentially, what would be the derivative of this thing? Because now we are told that the derivative of y in terms of x is equal to -2 at point r. Okay? At point r, because that is the point of tangency right there. So essentially, now what is the first derivative here? Mind you, these two are constants, because this is the complex constant. So it won't feature as part of the derivative. So this implies, maybe we can say, but wait. And then, of course, what is the derivative there? Sorry, this is minus x plus 1 is equal to -2, which implies that this is going to be minus x is equal to -3. Therefore, x is equal to 3. So we know that x at r should be a 3. So we can find that. Oh, Lord. We see that you are actually 3. Now we need to find the corresponding y value. And then this implies that y at r is going to be g at r, because maybe g at 3, sorry. Because g is the simplest that can help us to do this. So g at 3 is going to be 8/3, basically. So we can say, therefore, this point r is basically 3 and 8/3. Leave it like that. So does it make sense? 8/3 is a positive value. 3 is also a positive value. So most likely, it may be a matter of the numbers, but the solution is suggesting that it's a point in the first quadrant, and we can accept that. Okay, great. Now what do we want, guys? We want the y value. Okay. I'm trying to think now. Oh yes, the y value at r is that. So basically all we can say here, we can say therefore, okay, maybe let's start with our essay and say then. Remember, we were told that these are equal there. So this means f, or this shenanigan right here, this y, this function here, whatever name it is, when x is 3, y is 8. So we can say then y is equal to 8. Or we can say 8 is equal to y. 8 is equal to y. But now what is y? This implies that 8 is equal to a half of x squared plus x plus 15/2 plus t, because that was y. Okay, not a problem. So, oh no, it's 8/3, ne? Yes, when x is a 2. When x is a 2. Or maybe let's do it this way, guys. Let's not be silly. Why am I complicating my life? Then this y equals minus half of x squared plus x plus 15/2 plus t. We know that point r is also a point on that function. So with r looking like this, 3 is to 8/3. Ne? It is going to be not like this when I'm an a when 8 over 3 is going to be minus half of 3 squared plus 3 plus 15 over 2 plus t. Very complex equation. 8 over 3 is equal to, now let's sort this one out. This is basically 9. Okay, let's just do that nicely. Let's just do all of that. So minus 0.5 into 3 squared plus 3 plus 15 over 2. Okay, so this gives us 6 plus t. Okay. So essentially we can transpose the 6. This implies that t is going to be 8 over 3. Can you see what I wrote here? Yes. Sometimes izinto nje zvele zifuna ulahleka msinya umlilo, ndiyanixelela ningazodlala umlilo ulahleka msinya. Therefore t, this question, you're looking at 4 marks, but it's hiding the fact that there's so much work you need to do. Okay, so 8 over 3 minus 6. So this is minus 10 over 3. Okay, so that is the answer I'm getting, guys. I don't care wrong or right. It doesn't matter now. It's a matter of making sure your substitutions are correct and everything is done properly. Otherwise, if you don't do anything properly, you're going to run into some situations or some problems. This is how these 18 marks could be scored. Obviously, the last 2 questions are higher grade questions. One can include grade 11. The second one is purely grade 12 because you need to think of derivatives. So you just differentiate there to get the derivative, but you know that that gradient is going to be minus 2. Again, you have to picture this somehow, that the sketch would look something like that, because it means we are vertically shifting our graph down, and as you can see, t is a negative number. And if t is a negative number, this convinces us that actually we are correct about t. Although this one may be an issue if we didn't perform our calculations properly, but you can see we are shifting this parabola down by those units, and we could see for a tangent on this one that is already below the parabola in that segment, it has to be shifted down for it to also have that point of contact there, and essentially to have that as a tangent. So this was a nice question, guys. I hope you enjoyed it, and I'm sure you guys scored the most marks. Perhaps your challenges would have come for 5.6 and 5.7. Otherwise, everything is maths, guys. There's nothing you can do about it. So of course, doing the derivative, it's a mark. So we've got 1, 2, 3, and essentially that one you don't really get a mark for it. It's your problem. So I think the derivative there and equating it to 2. Okay, maybe let's mark. Let's see, 1, 2, 3. I don't know, guys. I don't know. Maybe let's just give you 4 marks like that. Either way, the marks can be anywhere. Sometimes my marking guidelines are just arbitrary. Their formal guidelines will give you a proper direction. I hope you enjoyed the video, guys. I will see you next time. Bye-bye.